Hey, good day again, students. Last time we start at introducing unit cycle, the concept of unit cycle. A unit cycle is a cycle whose radius is one, and we delved into talking about the terminal points or the coordinates of our angles in unit cycle. We introduced cosine of the angle and sine of the angle. Uh, Moving on from there, we add some examples like this, and we ask the question, what is the cosine of the angle T? What is the sine of the angle T? And you can recollect that we say X is the cosine of our angle and Y is the sine of angle. So we learned that, and we also learn how to find the cosine and sine of angles such as 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So moving on, we introduce Pythagorean identity, where we claim that x squared plus y squared equals to r squared. And in the case of unit circle, our r equals to 1 in a unit circle, And then because of that, we claim that x squared plus y squared equals to 1 squared, which is 1. And since x is cosine of our angle, y is sine of our angle, then we have cosine squared of angle, let's say t, plus sine squared of angle t equals to 1. So we call this the Pythagorean identity. And we use it to solve some problems. Okay, if you're just seeing this, you can uh, go back to my previous video on this topic. So today, we are looking at how to find the cosine and sine of some special angles, such as 30 degrees, 45 degrees, and 60 degrees. So we'll start with the 45 degrees. And to do that, I will make, again, a unit cycle, uh, not a perfect cycle, but it will help us to do what we want to do. So let's say this is pi over 4 or 45 degrees. Pi over 4, 45 degrees. I can make something like this. And now this is 90 degrees. This angle is 45 degrees. Sum of angles in a triangle is 180 degrees. So um, with that, remember the radius of a unit circle is 1. Now I have a triangle behaving this way. Okay, so here is 45 degrees, here is 45 degrees, and we claim that here is 1. So I will say this is y and this is x. If you think about this triangle, feels like it's a right triangle, and at the same time, we have this angle equal to this angle. So behaving like isosceles triangle at the same time, where base angles are the same. And that means that this length is going to be equal to this length. So we claim that x equals to y. Let us see how that is going to help us find the cosine and sine of 45 degrees. Recall, we recall that x squared plus y squared equals to 1. And since x equals to y, I can replace this y using x. So say it is 1. So 2x squared equals to 1. I can divide both sides by 2, and I have 1 half. I can take the square root on both sides. So I will have plus or minus square root of 1 over 2. And x equals to plus or minus 1 over square root of 2. However, I do not want to have square root at the denominator, so I can rationalize that by multiplying by root 2 over 2. And that gives me plus or minus root 2 over root 4, which is 2. Now, we know that our angle is in the first quadrant where x is positive. X is positive here. So we can conclude that x equals to square root of 2 over 2. And remember that x equals to cosine of angle, in this case, 45 degrees or pi over 4, which is root 2 over 2. That is cosine of 45 degrees. Also, we know that x equals to y. And our y is sine of our angle, 45 degrees. So if x equals to y, remember our x is this. So it means that sine of 45 degrees equals to root 2 over 2. So we also have D. So conclusively, we have cosine of 45 degrees or pi over 4 to be root 2 over 2, and sine of pi over 4 or 45 degrees to be root 2 over 2. I'm using 45 degrees and pi over 4 interchangeably because they are the same thing. One is in degree, one is in radian. At the same time, for you to know, for you to be familiar with this angle. So once you're familiar with them, you can stick to whichever one you are working with. Again, here I said find the sines and cosines of 30 degrees. I have something like this. I need to also do the geometry to introduce geometry in a way. So let's say this is 30 degrees. 30 degrees. What I can do is to do something like this. So this is 30 degrees. And I can do this. So in that sense, this is 90 degrees. This is 60 degrees. I can complete it this way. So this is, here will be 30 degrees because it's the same triangle that I'm having there, just manipulating that triangle to be useful for me. So here is 60 degrees. In that sense, I have something like this. Something like this. So this is 30 degrees. This is 60 degrees. And this is 90. This is 30. This is 90. And this is 60 degrees. And now we can see that this angle is 60. This angle is 60. This angle is 60. It has a special name. And that is, we call it equilateral triangle, whereby all sides are equal. So if this place is 1, radius of a unit circle, here is 1. So we are claiming that here is 1, here is 1. Then this side as well is going to be 1. Now, since this is dividing that triangle into two, then I can say this is half and this is half. 1 half, 1 half. So let us keep going. I can bring out that triangle this way. Now I can find sine and cosine of 30 degrees. 90, and here is 60 degrees. Here is 1. I don't know this place. I will call it x. I know my y, and it is 1 half. In fact, we do know that x squared plus y squared equals to 1. That is from Pythagorean identity. Pythagorean identity. Okay, we know what y is. So we can find x. X squared plus y is 1/2 squared equals to 1. So x squared equals to 1. Okay, let me do one more step. 1 plus 1 over 4 equals to 1. So x squared equals to 1 minus 1 over 4. Collecting like terms, x squared is 3 over 4, 3/4, if you subtract this fraction. And then we can take square root on both sides. So x equals to plus or minus square root of 3 over 4. With that, we have that x equals to root 3 over 2. I'm going to stick with plus because the angle is in the first quadrant. The angle I'm looking for is in the first quadrant. So, and x there is positive. X is positive. So I will use positive for root 3 over 2. Now I know that x is root 3 over 2 and y is 1/2. We already have that from here, 1/2. Therefore, cosine of 30 degrees or pi over 6 is root 3 over 2, and sine of 30 degrees is 1/2. So again, we have been able to find uh, the terminal points or the coordinates of 30 degrees. So x is root 3 over 2 and y is 1/2. So for 60 degrees, again, we return to the same approach and use geometry to help us. So let's see the method we are going to use here. 60 is somewhere like this, 60 degrees. Well, I can do something like this. And I can, bisect that line. Remember, here is 1, 1. Here is 1. So I can divide that into 2. So this becomes half. Here becomes half. So this is 90 degrees. Here will be 30 degrees. And do we need any other part? Not really. Here is y. So I can do this, add this. This is one way to find what we are looking for. So this length is 1/2. Here is 1. Here is 60 degrees. So we already know x in this case. We are left with y. So we do the same thing as we did earlier. So since, let us make some conclusion here. Since x equals to 1/2, it implies that cosine of 60 degrees or pi over 3 is 1/2. Done. Now, using Pythagorean identity or using Pythagorean identity, we know that x squared plus y squared equals to 1, which is the same thing as cosine squared of our angle. In this case, 60 degrees plus sine squared of 60 degrees is 1. So we know cosine of 60 degrees is 1/2. So we just need to square that, plus sine squared of 60 degrees equals to 1. Therefore, sine squared of 60 degrees equals to 1 minus 1 over 4, taking the square of 1 and 2. So this is 3 over 4 sine squared of 60. Now to find sine of 60, we need to square root both sides so that this becomes sine of 60 degrees equals to plus or minus. We need to introduce that 3 over 4. And again, we have plus or minus root 3 over 2. Now, since our angle is in the first quadrant where y is positive, then we can conclude that sine 60 degrees equals to positive root 3 over 2. Answer. So again, we know cosine of 60 and we know sine of 60. So in sum, we have it here. We have our angles and we have cosine and sine. Let us quickly see what we've done. For 30 degrees, the cosine of 30 is root 3 over 2, sine of 30 is 1/2, and so on. For 45, for 60, we already know how to find this from just the unit circle itself. Okay. Now, let us bring everything together. You can see for 30 degrees, we call this the coordinates or the terminal points. So these are the values, the cosine and the sine of that angle. In this case, our angle T is 30 degrees. So the same thing with 45 and the same thing with 60 degrees or pi over 3. So we will be using this idea, this point, this, and this. 1, 2, 3, 4, 5. These 5 angles will enable us to be able to talk about all the angles in the unit circle. Although we only find all the angles in the first quadrant. Now, how do we find all other angles? In the second, in the third, in the fourth. The beautiful thing is these angles that you know in the first quadrant, these angles you know here are called reference angles, of which their values are also the angles of other special angles in quadrant 2, quadrant 3, and quadrant 4. The only thing we need to introduce is the signs. For example, any angle that is in quadrant 2, the x value there is negative and the y value there is positive. Any angle that is in the third quadrant, the x value there is negative and the y value there is negative. Any angle that is in the fourth quadrant, the x there is positive and the y there is negative. So let us see how we can make use of this idea. So the concept of reference angle. Just like I said, angles have cosines and sines with same absolute value as cosines and sines of their reference angles. The sign, be it positive or negative, can be determined from the quadrant of the angle, just like I explained. All my explanation is here. Let us look into example. Now, how do we find reference angle? We first need to know reference angle. Remember I said 30 degrees 45 degrees, 60 degrees are all reference angles to other angles in the unit circle, to other special angles in the unit circle. Now, the question is, how do we find which of these is the reference angle for a particular angle in other quadrants? Let us take example, 150 degrees. In general, before we take example, all you need to do is, suppose we have a unit circle, whose angle, let's say remember it has to be an angle in its standard position, starting from here. So let's say we have it in the second quadrant like this. Okay, let's say this is our angle. Now, suppose our angle is, say, 120 degrees. To get the reference angle for this 120 degrees, all you need to do is to come to the terminal side. You remember what terminal side is? This side. Come to the terminal side and find the value of the angle between the terminal side and the horizontal axis. In this case, it is going to be 60 degrees. So you've been able to find the reference angle for angle 120 degrees. That is how to do it. Suppose our angle is in third quadrant. All what you need to do is, let's say the angle is like this, up to this point. To get the reference angle for that angle, all you need to do is add this angle to 180. Right? This is one measure, rather, excuse me. What is the measure of this angle between this terminal side and the horizontal axis? So that will give you the reference angle. Let us work with example to make it clear. So in this case, find the exact value of cosine of 150 degrees and sine of 150 degrees. So these are unit circle. We have this, we have this. Beginning from this side, the initial side. So 150 degrees is going to be somewhere here. Remember, this is 180. So here would be some 150 degrees. Now, here to here is 90. So which means here is 60 degrees to make it 150. And now, our reference angle is going to be the angle between this terminal side and the horizontal axis. So in this case, it is 30 degrees. Because again, everything here is 90. So 30 degrees. So we claim that the reference angle for 150 degrees is 30 degrees. Now, what do? We know that the terminal points, or the coordinates, the terminal points for angle 30 degrees is, do you remember that? Root 3 over 2, comma, 1 over 2. You should know those important angles of this for 30 degrees, right? For 30 degrees. So that is the terminal point. Now, all what you need to do now is to say cosine, therefore, cosine of 150 degrees is going to take this value, but the sine, just come back here. Come back to the angle. Our x there is negative, so it's going to be negative. And sine of 150 degrees is, for sine, y is positive here, so it remains 1/2. So that is our answer. Remember how to find reference angle. Just find the angle between the terminal side and the horizontal axis. Done. That becomes the reference angle. And you use the terminal point for that reference angle because we know it to find the cosine and the sine of the original angle you are looking for. The only thing you need to look for is the sines, which will be determined by the quadrants in which the angle falls into. Let us also consider this example. Using a reference angle, we have to use reference angle strategy. Find cosine of 5 pi over 4 and sine of 5 pi over 4. This is not in degree. You can convert it to degrees, but not necessary. There is a way you can think about this. Let's have, again, unit circle. Remember, 5 of what? Pi over 4. We know that this is pi over 4, angle 45 degrees. 5 of that. We have 1, we have 2. Remember, from here to here is 90, which means we have something like another pi over 4 here, which is 3, another one, which is 4. So automatically, the fifth one is here. So from here up to this point, we have 5 pi over 4. Now, we know where it is. What is the reference angle? Where? It turns out that the reference angle itself is pi over 4. How do I know? The angle between this terminal side and the horizontal axis is pi over 4. Okay, if that is not clear enough, remember from here to here is pi over 4, 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 here to here is pi over 4. So that is how I figure that out. Now, reference angle for 5 pi over 4 is pi over 4. We know that. Now, the terminal point or the coordinates, the terminal point for that reference angle pi over 4 is, you should know this also by now, root 2 over 2, comma root 2 over 2. Therefore, we can find cosine of 5 pi over 4. And we can find sine of 5 pi over 4. Again, it will be root 2 over 2, root 2 over 2. But we need to figure out the signs. X is negative here, which means cosine will be negative. Y is negative here, which means this also is going to be negative. So that is how to figure that out. So I will leave this one for you to do. Use the reference angle to find 315 degrees and cosine of 315 degrees. Oh, sorry, use the reference angle of 315 degrees to find cosine of 315 degrees and sine of 315 degrees. All you need to do this, do this, do this. And where do you have 315? Remember, you start from here, you move, because it's a positive angle, so you move in this direction. So wherever you have to stop there and find the reference angle and solve that. Okay. What about this? use the reference angle again of negative pi over 6. Let me push you a bit on this. Negative pi over 6. Remember, if we are having our initial side starting here, negative pi over 6 means we are going to move in a clockwise direction. So we have this, something like that, pi over 6. Okay? Now, the question is, let me make this bigger. Let's say pi over 6. Okay, pi over 6. We move this direction. Now, the question is, what is the reference angle? Well, this is also the terminal side. This is the terminal side. Uh, this side. This is the terminal side, right? So what is the angle between this terminal side and the horizontal axis? It is still pi over 6. And remember, pi over 6 as terminal points to be root 3 over 2, comma 1 over 2, right? So we do have that cosine of negative pi over 6 is, now, so it means we have the same terminal points, but the sign will be different. Well, for here, x is positive. However, y is negative. So here is negative. So cosine of negative pi over 6 is root 3 over 2. And sine of negative pi over 6 is minus 1 over 2. It is as simple as that. Find the coordinates or terminal points of the point on the unit circle at an angle 7 pi over 6. I will leave this for you to do, so you can pause this video and work this out. Remember, pi over 6. It is a positive angle, so you go, that is in your head. By now, you should be smart enough to be able to move around this radian and degree. Pi over 6 is 30. 7 of that is 210. So you can know where that falls into, right? So should be able to do that. Or you can move in 30, 30, 30, 30, 30 until you get to 7 of that. The same thing with this. The same thing with this. 5 pi over 3. And lastly, the same thing with this. Negative 5 pi over 2. So that you remove in clockwise direction. Pi over 2, pi over 2, pi over 2, pi over 2, then pi over 2. 5 of that. So I hope that is simple enough for you to take care of. So you should be able to solve these 3 problems without any difficulty. So in the end, let me see. In the end, you should be able to get something like this. So you should be able to get something like this in your computation. You should be able to get something like this. Okay. Further examples, evaluate sine of theta and cosine of theta if theta is negative 3 pi over 2, which is, I'm just going to be very fast here. So negative, I'm going to be going in clockwise direction. 1, 2, 3. Remember, cosine of negative 3 pi over 2 is sine of negative 3 pi over 2 is, so Remember that here we have 0, comma 1. So for cosine, 0. For sine, 1. In this place, y is positive. Well, it is what it is. It's what we have there, right? So it is that, right? Um, so remember, 1, remove 1, 2, 3. So clockwise. So we are there. So it's in the on this axis, right? So we have that. Um, another one. What's another one? So negative. Let's see this. Negative 5 pi over 3. Negative 5 pi over 3. So our angle here is this. So cosine of negative 5 pi over 3 sine of negative 5 pi over 3. Again, let us think about it. Pi over 3, that is 60, right? That is 60. We want to move in clockwise direction 5 times. So here we have some 60 here, 60 here, 60 here. We have 3 up to 180, right? You have 3. So there's another one here. So the fifth one should be somewhere here in the first quadrant. So remember that if you're finding the reference angle, so this is from here all through to this place, we have 270 already. That is from here up to this place, that is 270. We need 30 more here. So from here to here, that is the reference angle, is going to be 60 degrees, right? And now, what is the terminal point for 60 degrees? We do know that is half, comma, root 3 over 2. So for cosine, it is 1/2. For sine, it is root 3 over 2. So since that angle is in the first quadrant, both of them will be positive. So done. So I'm going to leave you with these two problems. So you can pause the video and try to solve this on your own. You should be able to solve this now. Look for where that angle falls into, the quadrant it falls into by counting, or this way, depending on the sign. Find the reference angle, the terminal point for the reference angle, then use the position of that angle to determine the sign, and that is it. So in general, we have what we call the unit circle, uh, having the values of the uh, terminal points, that is the special angles and the corresponding points on the unit circle. So we have this. So you should always have this by your side anytime you are, working on anything related to calculus, because this is, you know, what we can call our calculator. Our calculator when you are dealing with calculus. So you can see all those special angles with their terminal points, everything, 120, 135, 150, 210, 225, 240, 300, 315, 330. So you can see this. All right. So we can talk about other trigonometric functions. So primarily we have sine of angle, t, for example, and cosine of angle, let's say t. We can derive other functions, other trigonometric functions from these two. So that is what we want to look into right now. So in general, um, oh, interesting. Cannot clean this. Okay. So in general, we have for tangents, we introduce tangent, secant, cosecant, and cotangents. So we introduce these four, making a total of 6. Okay, so we have the definitions here. Um, okay, I don't know why I cannot erase this, but it's fine. So tangents of some angle t is y over x. Remember, x cannot be 0. Another way to put this is to say tangent of some angle is, remember, y is sine of that angle and x is cosine of that angle. And we claim that the cosine of that angle cannot be 0. Okay? Secant of angle t is 1 over x. Again, x cannot be 0. So which is the same thing, that is secant of t is the same thing as 1 over cosine of angle t. So cosine of that angle cannot be 0 at that point. It cannot be 0. Cannot be 0. So the same thing with cosecant, which is 1 over y cannot be 0, which is the same thing as 1 over sine of t. And cotangent is x over y, which is, let me write it here, cotangent of some angle t is x over y. Again, the denominator cannot be 0 because we cannot divide by 0. So which is cosine of angle t over sine of angle t. So sine of angle t cannot be 0 at that point. So that is that. Let us solve one more example before I end this video. The point negative root 3 over 2, comma 1 over 2 is on the unit circle. Okay. Find sine of t, cosine of t, tangent of t, secant of t, cosecant of t, and cotangent of t. Let us start. Well, even from here, we know this is x and this is y. Definitely, we know that cosine of that angle is negative root 3 over 2. Done. And we know that sine of that angle is 1 over 2. We've already answered this. As simple as that. Now, the next one, tangents. So let's say A, B, C. Tangents. Tangent of some angle is sine of that angle over cosine of that angle, or you say you use, yeah, tangent of t is y over x, which is sine t over cosine of t. Okay, and that is, do we know sine of t? Yes, we know it to be 1/2 divided by cosine of t is negative root 3 over 2 from these two, right? So that is 1/2 times 2 over root 3. So that is, these two can be 2 here, 1, 2 here, 1. So I have negative 1 times negative 1 over root 3. Again, I don't want it to be in this form. I need to rationalize it. To do that, I just need to multiply by root 3, by root 3. And then I have here to be negative root 3 over 3. So that is tangent of the angle. The next one is secant. So we are done with this. Secant of t. Secant of t, which is 1 over x. Oh, there is one thing I should put here. Cosine of t cannot be 0. You must write that always because we cannot divide by 0. Okay, so here we know that x cannot be 0. It is important for us to write that. So which is 1 over cosine of t. Cosine of t is not 0. Now, equals to 1 divided by, what is cosine of t? We have it. That is minus root 3 over 2. Minus root 3 over 2. And that is 1 times negative 2 over root 3. And that is negative 2, 1 times negative 2 over root 3. Again, I do not want the denominator to have radical. So I'm going to rationalize it by multiplying by root 3 over root 3. And then I have minus 2 root 3 divided by root 3 times root 3 is root 9. And taking squared root of 9 is 3. So that is my answer. The next one is cosecant of t. You can write it as this, cosecant. Yeah, of t. Cosecant of angle t. So cosecant of angle t, so you can abbreviate it as, or shorten it as CSC. Cosecant of angle t is, if you check the formula we have above, is 1 over y. Again, y cannot be 0. Then there is. Okay. So this is 1 over sine of t. We do know that sine of t cannot be 0. Now, this is 1 divided by our sine of t is 1/2, right? Sine of t is 1/2. So 1 divided by 1/2, that is 1 times 2 over 1, and that is 2. And lastly, cotangent of t. Cotangent of t. Cotangent of t is 1 divided by tangent of t, tangent of t, where tangent of t is not 0. Or you can use cosine of t over sine of t. It will give you the same thing. However, since I already find tangent of t, so I can just use that. So this is 1 divided by tangent of t is negative root 3 over 3. So I have equals to 1 times negative 3 over root 3, which is negative 3 over root 3. Again, I do not want radical in the denominator, so I just need to rationalize that. So in the end, I will be adding negative 3 root 3 divided by root 3 times root 3 is root 9. Square root of 9 is 3. And then It feels like I can say 3a1, 3a1. So I have negative root 3 as my answer. Um, just checking to be sure everything is fine. Okay, so you can stop the video and try to solve these. It's the same thing. It's the same thing. Find sine of t, cosine of t, tangent of t, secant of t, cosecant of t, cotangent of t, when t is 5 pi over 3. The only difference between this problem and the problem we solved here is that here we were given the terminal points. In this case, we were not given the terminal points, we were given the angle. However, we just learned how to find the terminal points. You can find the reference points, get the terminal point for the reference points, then use the sine in the angle where 5 pi over 3 lies to know the sine. Then you can then proceed to finding all of this. So the same thing with this problem. In fact, here you were given sine of 45 to be this, cosine of 45 to be this. Evaluate tangent of 45. The answer is already given to you there. Sine of 5 pi over 6 to be this. Cosine of 5 pi over 6 to be this. Evaluate secant of 5 pi over 6. The question is, what is the formula for finding secant? Or how is secant related to the sine and the cosine that we know? So, guys, this is where I'm going to be ending this video, and we will continue from there in our next class. So, I hope you enjoyed the video. See you in class. Bye-bye.